Okay, my name is Laram Lancaster, and I am going to teach you how to build advanced functionality into your families. Other people have discussed other aspects of family creation this evening, but I am going to cover three main topics: how to use check parameters, how to switch out family components via parameter, and how to build arrays. The primary point of this presentation is to build arrays, but you need to be able to do the other two things first, so we're going to jump right into that. A check parameter is a parameter used in a family that is not the one the user actually sees. I assume everyone here has typed a value into Revit that they thought would be in inches and it turned out to actually be feet, or vice versa. Typos happen all the time. Even well-intentioned values entered into a family can, under the wrong circumstances, cause the family to break on the user. The primary job of a check parameter is to avoid most or all of these occurrences. It's better for Revit to return a strange value than to outright crash. The primary job of the check parameter is to keep it from breaking, and we will discuss how these parameters are used within the arrays later, but just to get used to it, I'm going to switch over to Revit and we will see some of these as they're used. So this is a clear floor space that will be put on a door, and in it there are a couple of check parameters. Most of them are visibility ones, but the one that's easiest to understand is this check offset from wall. There's an offset from wall that the user will use, but this one is one that will modify the value and keep it within 8 inches. So the dimension that is being used in the family proper is the check parameter, and the one that the user sees is this one up here, and when they place a value like 4 inches into it, it passes through this if-then statement and returns a value. And 4 inches is fine, 7 inches is fine. You'll see that over here my family is moving properly, but when I put in 1 foot, then it is not fine, that it maxes out at 8 inches. I can put in any other higher value I want, and it will still only return 8 inches. But the moment you go back to something that's valid, it will move properly. So that is what a check parameter actually is. That you can use check parameters that are length values, like this one. You can use check parameters that are yes/no values, and we will get to numeric and integer values later, because those are the ones that we use for arrays. So the third bullet here is about adhering to code requirements, because that's a way to use these parameters that's fairly useful other than for arrays. The clear floor area family is built to have that 8-inch offset because that's what the ADA push-pull requirements are. I didn't make that up. I, as a family maker, would have no reason to arbitrarily limit the end user of this family, but when the limitation is imposed from the outside, I can keep the user from making an unwitting mistake. Switching family components via parameter. The main reason for this is so that instances have different conditions but are fundamentally the same, but one of the things it also allows is for fewer families to be loaded into your model. The classic example for this for architects is window surrounds. You can have trim surrounds, you can have brick headers and sills of various types, precast ones, but if you're loading these families separately and you need to build that up on the wall and host them individually, then you're loading a lot of extra elements into your project, where if you just loaded a window that had sub-nested families in it, the same window can be in a brick wall and have a brick surround, and another window be in a trim wall and have a trim surround. And that is a way to switch these out. The graphic that I'm showing here is back to the push-pulls, because when we go back to Revit, I can load up the door family, and the door family here has various push-pulls on it, and I can change this push to any other push, and it is reacting properly and the pole can react, and the fundamental size and shape of this door has not changed. From scheduling purposes, the height's the same, the width's the same, the door panel's the same, the lock set is the same. This is the exact same door, and you can use it in two different instances, and one instance will be a front approach and one instance will be a side approach, and that's the way you can switch these out via parameter that way. Building arrays, which is our next and final step. The unfortunate thing is arrays are heavy on system resources. That, be sure that you're going to use a family that needs an array, or you can even have two families, such as the window I'm showing, one that has the array for the mountain grid and one that doesn't have the array, because if you're not going to need it, don't have it in your project. It's additional system resources that you're just going to blow through. That's not necessary. The arrays can affect your video card performance in the way you're moving around a model based on their joins and things like that, or they can affect your processor lag after a command, that you can hit a command and then wait 2 seconds and then it'll actually do what you asked it to. But by the time you're considering an array, you're pretty much sure that it's worth the trade-offs, so it's mostly just a reminder that the added functionality that you're gonna get, that you've decided you want, does come with a cost. Don't be surprised if Revit slows down a little bit because you're putting arrays in a component that's going to show up 100 times throughout your model. The first thing to never forget about an array is that it can never ever have less than 2 elements. It will immediately explode. That is why we discuss check parameters. This is an ideal place for one. If you proceed without one, you do so at your own risk, because then someone can input a value into the parameter that says 1 and boom, it blows up. So you give the user a value that allows them to put in 1, 2, 5, 20, 0, -3. Doesn't matter, the check parameter will provide a value of 2 or higher always. The static elements in this context is something that will never change. That you can't, if you're going to do a 2x4 that is 1.5 inches by 3.5 inches by 8 feet, always, no matter what, you can model that in your family live, and you can array that out and it will work okay. But the moment you need to dynamically change it, and it needs to change height, change depth, change thickness, any of those things, you need to have a nested family that you are arraying that is flowing through those parameters, because the requirement comes from how arrays use groups. If you attempt to dimension or align elements within groups to elements outside the group in any manner that you would normally use to control normal family geometry, those efforts break. The array becomes entirely uncontrollable from a parameter standpoint, the way you would expect other sweeps, extrusions, and things to be controllable via parameter. So the optimal arrays will have 3 nested layers. You can do it with 2, but optimal will have 3. You'll have your final host family, which you can see here is the truss. You will have a grid family, which is the intermediate step, and then you'll have the individual element that is being arrayed out. The most common middle family is a line-based family, which is what I'm showing here. And it can stretch in length with easily controlled end conditions, but you can sometimes have a waffle pattern or any other type of sub-family that you're going to load in, but controlling the array into a simplified family or controlling the element into a simplified just array family and then putting that array places is the way to go. Because by being work plane based, this middle grid family is work plane based, you can move it into any orientation in the host. You can use 2 of them, you can use 5 of them, you can use them vertically, horizontally, wherever at an angle, wherever you need them. And you can do that with much greater ease because you've built an array family rather than trying to array one item in 3 different ways in 4 different places in your host. So the 3 layers of nested families is very useful. Be sure that you remember to connect the dots between your element and your final host through the mid family. The whole point of using this array step is because you have parameters that need to make this element change, and if you forget to link them through, you're going to have problems, and you need seamless functionality for the user, because they just expect to type in a value and for it to just happen. So don't forget that. And finally, I'll explain this more when I actually build an array, but I prefer first-last arrays over first-second arrays. A first-second array takes a defined distance between the 2 elements and repeats that spacing in whatever direction the user says up until the count is satisfied. If you have a 5-foot spacing and you have 3 elements, you're up to 15 feet. But if you try to define 17 feet, you won't get there. There'll be a remainder that'll hang at the end of your family, and there'll be a gap, which is the added benefit of using the first-last array, is that there'll never be a remainder. You'll say, I want 4 elements, and I have 17 feet, find whatever spacing makes that fit. Or 3 elements, and there'll be slightly more than 5 feet, or whatever. In your main model, you can use either of these to suit your needs. They both have their benefits and uses in main models, but within family creation, and specifically within this grid family that we're talking about, the first-last is the primary method of moving your arrays around. So back to Revit. Let us load up this truss that you were just looking at, this truss grid. Whoop, that's the wrong one. That is, well, that's the truss post. I want the web brace. Okay, so here we have a fully functional, fully working array. I can change the width of these elements if I need to, and they get fatter. The thickness is in a direction you can't see from this angle. I can change the height of them to 3 feet. And they will all morph properly in their arrayed fashion. The count is currently 4. We can set it up to 6, and more of them will show up. So that is this array is already ready to go. But let's look at how to build this. So I'm just going to take these and delete them, and we will do this from scratch. So step 1, place your element. Step 2, link all your parameters together, because we don't want to miss this step. We will link together the space width, the post length, post faced width, and post thickness. Okay, so our arrows have turned into dots because it is being controlled via a parameter. And then we can just jump right into the array tool, because all of the controls on the array come after it's been built. These are your values for the array. Please note that we are in a linear array at the moment because we are doing a linear line-based family. You can do these arrays in a radial fashion. It works in the same method, but this is linear. I will use 4 elements here because that will immediately show me what's happening with this second last. If I put in 4 elements and they fall off the screen, that's because they're going first to second, and then they're going as far as I want them to. If I do first last and I provide a short length, then you will see all of those elements fill in. So we will just do a short distance that way. This is exactly what we were looking for. It's a proper first last array. So now that we have our first last array, the next thing we need to do is we need to link together the final piece, which is the post count. And so that will immediately update to 6, and all of our parameters are now live with this array. However, it is not following the grid shape, and it is not aligned to anything yet. So you Some people will be tempted to edit the groups, the first element, and try to do the align in here, and then go to the last element and do the align in there. The issue with that, however, is that you will often get over constraints in your sketch, and it will break in funny ways. You open yourself up for more problems than you're worth. So I would just do it outside in the main portion of the family. The first highlight we get here is the shape handle. The second one would be reference if there was one. The reference one is the one you would want if you have that functionality in your subcomponent. But if you don't, just go for the shape handle. Always go for references if you can. They provide better arrangement and attaching to reference planes. So the left and the right are fairly straightforward. They're just simple aligns. The top and bottom, however, are different. And the reason that is the case is because the left and right are this group going to this reference and this group going to this reference. So the two groups are going to different places. However, when you're going down, they would both be going to the same reference, and that will give you, or potentially give you, a elements are over constrained error. So instead, we're going to dimension on this side and then dimension on this side, and provide the value of the height of the element, because the height of the element, because it's defined to be that high and the top of it being that far from this reference, will lock it into this position. This also has the added benefit that if you ever want to stair step your array, you can change one of these parameters to something else and it will step accordingly. So now we have a fully functional array that is completely responsive, and those are the steps you need in order to make that work. If we go to our full truss, you can see that we currently have 4 elements in the truss right now. We can switch the length to something shorter, and it will change the array count automatically. The interesting thing about this is that the length here isn't actually the true length. There's a check length happening based on the size and shape of this truss. So the 4 feet, even I could put it down to 1 inch if I want, and you don't see 1 inch happening. That's also where the check length is coming into play. Another interesting point of note is that if you look at this, it's easier to see in this truss post grid that here we have the post on the inside of the reference. And if I go to this Muntin grid family, which is a slightly different thing, it's laid out a slightly different way, you'll see that this is on the outside. And so your grid family becomes a very important way for you to organize exactly how the array is going to behave. This one is set up so that when you define a length, the muntins fall to the outside and will actually be hidden in surrounding geometry. And this is the way in which, if I go to the window that these muntins are for, I can put one light, which is no muntins, and they look like they disappear. It looks like that there are no elements in these arrays, but that is because the array is actually over top of the sash on the sides and is being held to the outside, and only when I put in additional lights, 2 lights high, 2 lights wide, 4 lights, and it'll respond in that way, because there's always elements on the outside and your additional ones are in the middle. So that is my quick tutorial on arrays. Thanks for being here, and because this is a YouTube video, thanks for watching.